The lesson topic for this video is more properties of exponents. Okay, now the only new property we're going to talk about today are negative exponents. Now, a negative exponent looks like this, so x to the negative 2. I have a way that I prefer that we think about negative exponents, and that is, let's make them not negative. I don't like to deal with negative exponents. Different teachers teach this different ways, but I like to turn it into not negative. So in order to do that, we're going to make every problem that we do into a fraction if it is not already in that format. So I'm going to take this, I'm going to put this over 1. So what I talk about when we do these is I'm going to put this fraction bar here. I don't want my negative exponent. So what I always say, and here's my phrase, I'm going to type this out so it's nice and neat. I say, move it and make the power positive. If I could spell, sorry you guys. All right, move it and make the power positive. So what does that mean? That means we're going to move it to the other side of the fraction. So x to the negative 2, I'm going to move down to here and make the power positive. 2. Now this 1 right here is still here, so we can write that if we want to, we don't have to. So it's 1x squared in the bottom. Now what is in the numerator? Well, remember, there's always something in the numerator because think about this. Over here, this was actually a 1 right here, right? So that 1 is still here. So our final answer for this problem is 1 over x squared. We move it and make the power positive. Let's try a couple more of these before we look at some more complex examples. So let's say I have x to the negative 3 over 5y. Okay, we want to simplify this. Simplifying exponents means that we always need to write them without negative exponents. So here we go. Let me change this problem just slightly. Let's put a 4 out in front right here. There we go. Got it? So 4 times x to the negative 3rd all over 5y. So here's how I do this. I think about, do I keep it or move it? This 4 right here, I keep it. It doesn't have a negative exponent. So I keep it where it is. Next, x to the negative 3. It has a negative exponent. So we're going to move it. So I move it to the bottom and I make the power positive. Now I look at the 5. The 5, we're going to keep it where it is. It doesn't have a negative exponent, so it's going to stay on the bottom. Now it doesn't matter where you put it. You can put it in front of the x to the 3rd. You can put it behind it. It does not matter. I'm going to put it in the front. And now the y. The y doesn't have a negative exponent, so we keep it where it is. So it stays there. So here's our answer, you guys. Our answer is 4 over 5 times x to the 3rd times y. There's nothing else we can do to simplify this. All right, another one. How about negative 3x over 4x to the negative 2. That's enough. That's good. Let's do that. So negative 3x over 4 times x to the negative 2. All right, so first things first. Do we move this or keep it? This is actually a very common mistake people make. Just because it's a negative number does not mean it has a negative exponent. So we are going to keep it where it is. It does not have a negative exponent. X, we're going to keep that where it is too. It doesn't have a negative exponent. Down here, 4. 4 does not have a negative exponent. X to the negative 2. This has a negative exponent. So we need to move it and make the power positive. We move it to the numerator, x, and make the power positive 2. If you want to put a time sign in between there, right here, you can. All right, now we need to simplify because it is not fully simplified. This is going to equal negative 3 what we have here is the product rule. Base of x raised to the 1, when there is no exponent, it's a 1, and base of x raised to the second. So keep the base and add the exponents. 1 plus 2 is 3. And then the 4 in the denominator stays there. And we're done. Okay, so let's try a couple of examples. The first one, x to the negative 2. Again, we're going to turn this into a fraction. And now we are going to decide if we move it or keep it. X to the negative 2 has a negative exponent, so we are going to move it, and we're going to make the power positive. So x and make the power positive. This 1 I could write right next to this, but I don't need to. And the numerator, of course, still has a 1. Always a 1 right out here. That's it for that one. All right, the next one. Now, the first thing we have to do is remember from previously in class, we need to give everything in the parentheses the outer exponent. So how I'm going to do this is I'm going to say, all right, x to the third gets raised to the negative 2. And y to the negative 4 gets raised to the negative 2. Now what do? Well, now we're going to use the power rule. Notice right here we have two exponents right next to each other. That means you are going to multiply them. So keep your base and multiply your exponents. 3 times negative 2, which is negative 6. And now we have a base of y, and we have 2 powers on it. 2 powers here, so we multiply those powers. Negative 4 times negative 2. Well, negative times a negative is positive, and 4 times 2 is 8. Now, we are not done yet, because we have a negative exponent. So I'm going to go ahead and put an equal sign here. I'm going to put a fraction bar. We always turn it into a fraction. So now, x to the negative 6 has a negative exponent, so we move it to the other side of the fraction and make the power positive. And the y to the 8th does not have a negative exponent, so we leave y to the 8th where it is. This 1 right here, if we wanted to, we could write this 1 right here, but it's not needed. This is our final answer. We cannot simplify things that have different bases, like x and y. Okay, the next one. All right, so there's no outermost exponent that we have to get to every term or every factor. So instead, I'm just going to write equals and write another fraction bar, and then again decide if things need to move or stay. A to the negative 3, we need to move it and make the power positive. B squared, we keep it where it is. It does not have a negative exponent. Sorry, that's a 2. In the denominator, a to the 5th, it does not have a negative exponent, so you keep it where it is. You don't move it, you keep it where it is. So a to the 5th. Now we can simplify just a little further. The b to the 2nd power, we can't do anything with that. That's going to stay b squared. But in the bottom, we have a to the 3rd times a to the 5th. When we have 2 of the same base, and they're being multiplied, we add the exponents. So we have a to the 8th. 3 plus 5 is 8. Again, if we wrote this out longhand, it'd be a times 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 a, which was 8 a's being multiplied together. That's our answer there. Okay, one more. On this one, again, I'm going to look at my outermost exponent, and I'm going to give every single factor that exponent, because there's no addition or subtraction happening in the parentheses. So 3 squared, a to the negative 4 squared, 2 squared, because these parentheses are around the entire thing, so everything gets squared, and b squared squared. All right, to simplify this, first thing we have is 3 squared. 3 squared is 9. 3 times 3 is 9. And now we have a to the negative 4th to the 2nd right here. Okay, that becomes a to the negative 8. A to the negative 8. We multiply the exponents. In the denominator, we have 2 squared. 2 times 2 is 4. And then we have b squared squared right here. And b to the second is b to the 4th. Again, we are still not done because we have a negative exponent. We're getting there. I'm going to leave the 9. It doesn't have a negative exponent. I'm going to move and make the power positive. The a to the negative 8 becomes a to the positive 8. In the denominator, I'm going to keep the 4 in the denominator, so I'm going to bring that to the front. And I'm going to also keep b to the 4th in the denominator. And I'm going to put this here, just because now it's alphabetical. It really doesn't matter, but it looks best to me. And there you have it. Okay, if you want to try these two on your own, you should pause the video, try them, and then check back to see how you did. I'll just include the answers and you can see how you did. Okay, so here are the 2 answers. If you did not get them, you can talk to me about it in class.